Hello friends. In this session we will discuss a method for calculating the last digit of a number. Let us say, for example, I need to find the last digit of 2 to the power 120. Naturally, had this power been smaller here, let's say this is 2 to the power 3, power 5, power 10, it may be possible for me to actually calculate the complete number and then see what is the last digit. However, as the powers increase, it may not be possible for us to physically calculate the number and then see what will be the last digit. Therefore, this is one of the very frequent, very common question types in CAT and in pretty much any other competitive exam, MBA entrance exam that we would be writing. So, there is a general method that we use for calculating the last digit of any power, and which is what we are going to discuss now. Let us say, if I am looking at 2 to the power 120, let us start from smaller powers and then see if we are able to find a general pattern. 2 to the power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4, this will be 16, which means that the last digit is 6. Now, as far as the last digit is concerned, the last digit would depend only on the last digit. So let us say if I have to multiply 18 by 32, I do not need to worry about whatever is coming at the tens place in either of the numbers. For the last digit, I am interested only in the last one digit. So 8 into 2, 6. 6 will be the last digit of this number. Same idea would apply here also. For calculating the higher powers, as far as the last digit is concerned, I can focus only on the last one digit. So here I get the last digit as 6. 2 to the power 5 is 6 into 2, 12. 2 to the power 6 is 2 into 2, 4. 2 to the power 7 is 4 into 2, 8. 2 to the power 8 is 8 into 2, 16. 2 to the power 9 is 6 into 2, 12. 2 to the power 10 is equal to 4. What I observe from here is that as far as the last one digit is concerned, it is going in cycles. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4 would be followed by 8 and 6. This is one very important clue for us. What we can do using this is, whatever power is given to us, if we divide the power by 4, whatever remainder we obtain, the power corresponding to that will be our number. Let me explain. For example, if I am looking at 2 to the power 120, alternately if I observe from here, so from here what I have is 2 to the power 1 is of the form 4k plus 1, which will give me a remainder of 2. 4k plus 1 is 2. If k is equal to 1, 4 plus 1, 5. 2 to the power 5 is again 2. 2 to the power 9 is again 2, and so on and so forth. So if the power is in the form 4k plus 1, the remainder is 2. If it is in the form 4k plus 2, the remainder is 4. 4k plus 3, the remainder is 8. And 4k plus 4, or alternately 4k, the remainder would be 6. So now all I need to do is, I need to divide this number by 4 and see what will be the remainder. Also, as far as the divisibility rule for 4 is concerned, I do not need to divide the complete number. If I divide just the last two digits of the number, the remainder obtained when the last two digits of a number are divided by 4 will be same as when the entire number is, the remainder obtained when the entire number is divided by 4. So, the remainder obtained when the last two digits of a number are divided by 4 is the same as the remainder obtained when the entire number is divided by 4. So, in this case, I do not need to divide the entire 120. I can focus on the just last two digits. 20 divided by 4, remainder is 0, which means that the number is of the form 4k. And if the number is of the form 4k, the remainder will be 6. Oh, I'm sorry, the last digit will be 6. So the last digit for 2 to the power 120 would be 6. Let me simplify this whole thing and present it in a much simpler format. Whatever power is given to us, the first step for us to check the cyclicity of any number. So of the last digit of the base. So number 1, check cyclicity. What is cyclicity? Cyclicity is the digits which repeat, after which the same numbers will start coming. So the cyclicity for 2 is 2, 2 to the 4, 4 to the 8, 8 to the 16. So 2486 is the cyclicity. Because the cyclicity is 4, next I divide the power by 4. And after dividing by 4, whatever remainder is obtained, I raise 2 to that power. So step 2, by the number of terms in the cycle, in the power cycle as we call it. This is also called cyclicity. So divide the power of the number by the power of the divide the power by the number of the terms in the power cycle. So in this case I'll divide by 4. Number 3, raise the base to the remainder obtained in step 2, and that's it, we are done. So in this case 20 is divided by 4, remainder is 0, so I'll raise 2 to the power 4. Okay, this is again something that we need to bear in mind. 2 to the power 0 would not make sense. In case the number is of the form 4k, we need to raise it to the power 4 and not 0. That's the only minute thing that we need to keep in mind. 20 divided by 4, the remainder is 0, so 2 to the power of 4, 2 to the power of 4 is 6. So the last digit would be 6. Let's take a couple of more examples. Let's say I'm looking at 2 to the power 123. 23 divided by 4, 4 5 are 20 gone, remainder is 3. 2 to the power 3 is 8. So the last digit here would be 8. 2 to the power 15693. Once again, I'm interested only in the last 2 digits. 93 divided by 4, 4 to the 8, 4 to the 12, remainder is 1. 2 to the power 1 is 2. So here the last digit would be 2. And so on and so forth. So this is the basic method for the powers of 2. Let us see what will be the pattern for remaining numbers which end with other digits. 1 will obviously any power of 1 will always have the last digit as 1, so the power cycle of 1 will be 1. For 2, like we just saw, 2 to the 4, 4 to the 8, 8 to the 16. 3 3 3 3 are 9, 9 3 are 27, 7 3 are 21, so 1. 4 is 4, 4 4 are 16, 16 4 are 64, so that's 4 6. 5 will always remain 5, 6 will always remain 6, 7 would be 7, 7 7 are 49, 9 7 are 63, 3 7 are 21. Once I get a 1, then the same cycle will start repeating. 8 8 8 are 64, 4 8 are 32, 2 8 are 16, 6 8 are 48, so 8 4 2 6 will be the power cycle. For 9, it will be 9, 9 9 is 81. Once I get a 1, the same cycle starts repeating. For 0, obviously, it will always be 0. So these are the power cycles for various for numbers ending in various digits. A couple of observations from here. In case the last digit of a number is 1, I don't need to worry at all. The last digit of whatever power, it will always be 1. Similarly for 5, 6 and 0 also. So if the last digit is 1, 5, 6 or 0, then it will always be same. In case the last digit is 4 or 9. In case of 4 and 9, what I observe is that in case the power is odd, because the cyclicity is 2, in case the power is odd, the same number will appear. In case the power is even, then the counterpart will appear. So 4 to the power 14, is even power, so it will be the counterpart, so this will become 6. In case I'm looking at 4 to the power 143, it's an odd power, so it will be 4 to the power 48. 4, 8 is an even number, so this will be 6. Let's say this is 9, so this will be odd, so this will be 4, and so on and so forth. Similarly for 9 also we will observe that the same cycle will be observed. 9 to the power 1 will be 9, power 2 will become 1 because now it is even. If I raise it to the power this 3, now this becomes 1, 2, 3, odd power, this will become 9. In case this is 4, this will be 1, and so on and so forth. So 4 and 9, they are also easily sorted. In this case we look for even oblique odd powers. For the remaining 4, 2, 3, 7 and 8, for these the cyclicity is 4, and because the cyclicity is 4, whatever power term we need to divide it by 4, whatever remainder is obtained, raise the number to that power, and that will be your last digit. Only thing to be kept in mind is that in case the remainder is 0, I need to raise the number to the power 4 and not 0. So with that the basics should be sorted. Now we will take a couple of examples. Let's take one more example on this. 11 to the power 12 to the power 13 to the power 14. Similarly 12, 13, 14, 15, 13, 14, 15, 16, 14, 15, 16, 17, 15, 16, 17, 18. You should take some time off here and solve these questions, and then you should get on with this video. Let us see how to approach this kind of problems. I'll first begin with the easier ones. 1 raised to the power anything is always 1. So therefore compulsorily this one will always be 1. Similarly 5 raised to the power anything is always 5, so this one has to be 5. 4 raised to an odd power is 4. 4 raised to an even power is 6. Because the second term here is 5, 5 raised to the power anything will be 5. So that means that this is 4 raised to an odd power. Now 4 raised to an odd power is 4, so this will necessarily remain 4. Now 2 major ones remain wherein we will need to apply our logic. I'm looking at 12 to the power 13 to the power 14 to the power 15. As far as the method goes, we need to divide the power term by 4 and check what will be the remainder. In order to check the remainder here, what I understand is 13 divided by 4 will leave me a remainder of 1. Now 13 divided by 4 leaves me a remainder of 1. So can I also say that 13 to the power k divided by 4, this would also leave a remainder of 1 only? Now whatever power term here, 14 to the power 15, this can be written as k. 13 to the power k, this becomes 1. If this becomes 1, this whole term, this can be written as 12 to the power 4k plus 1 whole raised to the power n. And if it can be written as 12 to the power 4k plus 1 raised to the power n, when this number is divided by 4, the remainder will be 1. 1 to the power n is also 1. So overall this becomes 2 to the power 1. 2 to the power 1 is 2. So the answer here will be 2. And in general this would be the method for us. Whatever is the second power, we express this in the form of 4k plus whatever is the remainder, and then we raise it to the power and see what will be the last digit of this number. Let's look at the next one, 13, 14, 15, 16. Now this time I've got a 14 here. This will become 13 to the power 4k plus 2 whole raised to the power n. Now as far as 4k plus 2 whole raised to the power n is concerned, if I go into a little bit of binomial expansion here, a plus b to the power n is equal to some constant c1, c0, let us say c0 multiplied by a to the power n plus c1 into a to the power n minus 1 into b plus c2 a to the power n minus 2 into b square dot 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 finally cn b to the power n. Now if I make this 4k plus 2, this will become 4k plus 2 raised to the power n is equal to c0 into 4k to the power n plus c1 into 4k to the power n minus 1 into 2 plus dot 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 till finally Cn into 2 to the power n. If this whole thing is divided by 4, all the terms will have a 4k, 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 4k. So each term when divided by 4 will give me a remainder of 0, except for the last term probably. In this case, because the last term is 2 to the power n, 2 to the power n when divided by 4 will also give me a remainder of 0 in case n is greater than 1, and definitely 15 to the power 16 would be greater than 1. So 15 to the power 16 greater than 1, 2 to the power greater than 1 divided by 4, the remainder is 0. If the remainder is 0, this becomes 13 to the power 4. 3 to the power 4, last digit is 1. So this last digit will also be 1. Looking at these 5 questions which are a part of the first example. The first one is 2 to the power 37. As you would recall, in the power cycle for 2, there are 4 terms, 2, 4, 8 and 6. Even if you don't remember this, we can always do this calculation right over here. So 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, the same cycle will start repeating. Anyway, the cyclicity is never more than 4. So 2, 4, 8, 6, this is the power cycle. 37 divided by 4, remainder is 1. 2 to the power 1 is 2, so the answer would be 2. Second one, 5 to the power 123. 5 raised to the power anything is always 5, so this will remain 5. 7 to the power 53. What's the power cycle for 7? 7 7 is 49, 9 7 is 63, 3 7 is 21. Once I get a 1, the same cycle will start repeating. So 7 9 3 1 divided by 4. 52 will be divisible. Remainder is 1. 17 to the power 1 is 7. So this will become 7. 333 to the power 444. First thing that we observe is that the last digit depends only on the last one digit. It does not depend on the whatever comes before this. So here 17 is effectively 7, 333 is effectively 3, 199 is only 9. Second thing, 3 to the power 444. What is the power cycle for 3? 3 3 is 9, 9 3 is 27, 7 3 is 21. Once I get a 1, the same cycle will start repeating. So I only need to divide this power by 4. For division by 4, I focus only on the last 2 digits. 44 divided by 4, the remainder is 0. If the remainder is 0, 3 to the power 4, 1, 1 is your answer. And finally, 199 to the power 2486. 9, if it is an even power, it is the counterpart, so it will be 9 counterpart 1, so this will become 1. So these would be the answers for these 5 questions. Let's take another example, example 2. First one, 13 to the power 27 plus 57 to the power 12. 13, 3 power cycle, 3 3 3 is 9, 9 3 is 27, 7 3 is 21, so 3 9 7 and 1. 27 divided by 4, 24 gone, power 3, 3 3 is 9, 3 is 27, so this part will give me a 7. 57 to the power 12, I divide this by 4, division by 4, 7, power cycle last term is 1, so this part will give me 1. 7 plus 1 is equal to 8, 8 is your answer. Second one, 11 to the power 12, 12 to the power 13, 13 to the power 14, 14 to the power 15. Now 11 to the power 12 will be 1, so this will give me a 1. 12 to the power 13, 2 power cycle, there will be the division by 4, so 4 3 is 12, 1 gone, so this becomes 2. 13 to the power 14, again division by 4, 4 3 is 12, 3 3 is 9, so this becomes 9, and 4 odd power will be 4. So overall 1 into 2 into 9 into 4, so 4 2 is 8, 8 9 is 72, so this will be equal to 2. Third one, 12 to the power 24, 13 26, 14 28, 15 30. A very important thing to observe here is that there is a 5 in one of the terms which are being multiplied. Because there is a 5, the last digit of this number will always be 5. Now 5 multiplied by an odd number will give me 5. 5 multiplied by an even number will give me a 0. Because I've got a 2 and 4 here, definitely the product of these three numbers will be even. And if the product of these three numbers is even number multiplied by 5 is 0. So even without calculating anything, I know that the answer has to be 0. Had this 2 been 5, let's say 7, and this 4 been a 9, in which case 7, 3, 9, all the three numbers are odd, then this product would have been odd. An odd number multiplied by 5 would have been 5. So in that case the answer would have been 5. Last one, which is a variant of this, 12 to the power 24, 13, 26, 14, 28, 15, 30. Because this is addition, now I will actually need to calculate this. So what we do is 12, 24, 2 power cycle last term, that will be equal to 2, 4, 8, 6. So this becomes 6. 13, 26, division by 4, 4, 4 is 24, remainder 2. So 3, 3 is 9. 4 even power is 6, 5 whatever power is 5. So 6 to the 12, 12 plus 9, 21 plus 5, 26. 26, 6 will be the last digit of this number.